chapter 7, finally here. And we are not doing everything in this chapter, so I'm covering like 4 sections probably of this chapter. So we are winding down. We will do a test after this chapter. Should be kind of an easier test because a lot of the stuff you've seen before, so kind of give you guys some more test points in case you've had a lower test score that you're trying to get back up for this quarter. So systems of equations. This is something that you have done. You did it in Algebra 1, Algebra 2. We're doing it again now. So today is almost all just review. We do have a couple terms that we're talking about. So a system of equations just means you have more than one equation at a time. The solution is just an ordered pair that makes both equations true. If it has a solution, we call it consistent. If it has no solution, it's inconsistent. So you need to know what consistent and inconsistent are. Consistent has a solution, inconsistent has no solution. We'll use those terms as we're going through this. In terms of a graph, and back when you were in Mrs. Keller's class, you guys first solved these by looking at graphs. So you would have a system of equations and you would graph both of them. So let's say you had a graph that looked like this. So there was your first line, and let's say this was your second line. What's the solution of that system? Right, the point where they meet. So this would have a solution of 2, 0. What would the graph look like if it's inconsistent, if there's no solution? Parallel lines. Okay. Now the downside of the graphing, in order to graph them and find your solution, first of all, your graphs had to be perfect, because if one line was just slightly off, you couldn't tell. But also, if your points aren't nice, it's really hard to tell from the graph. You know, if they had met at 2/3, 1/4. That's really hard to tell from the graph. So we aren't going to do ours by graphing so much. We are going to do algebraically. So there are 2 options for algebraically: substitution and elimination. Those words sound familiar, hopefully. So let's do a substitution one to start. Substitution involves taking one of the equations and solving for one of the variables. It does not matter which equation or which variable. So what do you want me to solve for? X in the first or second? First one. Okay, so if I get the x by itself, we just subtract the y over. Then you have to substitute it into the other equation. So we got that from the first one, so now I'm going to use my second one, and I replace my x with a minus y. So I took the first equation and solved for one of the variables. And then I replaced the x with that in the second equation. Then this is something we can solve. Add like terms, so you get 8 minus 2y equals 4. You subtract your 8, divide by -2, your y is 2. To find x, we can just plug that in. X is 8 minus y, which was 2, so my x is 6. And then I would like for you to write your final answer as an ordered pair. X comma y, so 6, 2. Nice thing about these, they are easy to check, see if you got the right answer. You can plug them back in. X plus y equals 8, so 6 plus 2 equals 8, that works. X minus y, so 6 minus 2 is 4. So I can easily check that I have the right answer here. Is that one okay?
Where did you get the 8 from?
This 8?
No, the 8 is like the 8 minus 2.
Oh, I plugged my y into that equation for x. Sometimes it's easier to solve for one variable than another. So for example, if I gave you this system and told you to solve that by substitution, what variable do you think you might solve for? Y in the first one. It's not the only option. You can solve for any of them, but that way you would avoid fractions. So completely up to you, but that's probably the easiest. So to get the y by itself, all you have to do is subtract your 2x. So the y is 5 minus 2x. And then what do I do with that? Plug it into the second equation. So the second equation is negative 4x plus 6 times y, which is the 5 minus 2x. So distribute our 6, add like terms. So if I subtract my 30, divide by negative 16, we get x equals 2. Okay, then once I have x, how do we get y? Plug it in. Y is 5 minus 2x. So that's 5 minus 4, so we get 1. So our answer is the point 2 comma 1. And again, you could certainly check that just by plugging it into both original equations. So the second option for solving these is elimination. Let's do one by elimination. Do you guys remember how elimination works? The idea is we want to be able to add these equations together and eliminate a variable. We do that by making their coefficients opposites. So we have to pick, do we want to eliminate x or y? X, okay. So this is a positive 2x. In order for me to cancel them and make it go away, this would have to be a negative 2x, right? So I need to take this second equation times 2. Alright, so you can multiply your equations by whatever you need to. You can multiply one or both. We did not change the first one. Second one, if we took it times 2, that's negative 2x plus 2y equals negative 6. If you had wanted to eliminate your y there, what would you have multiplied the second equation by? Negative 3. So they would be opposites, but the same coefficient. Okay, so then if we add 2x and negative 2x cancels. 2y and 3y is 5y. 1 and negative 6 is negative 5. Divide by 5 and y is negative 1. Once I have y, how do I get my x? Plug it back in. You can put it into either of the originals. Doesn't matter a bit. So if I put it into the first one, we get 2x minus 3 equals 1. So if you add over your 3, divide by 2, and x is 2. So my answer is the point 2 comma negative 1. Okay. You guys want to try one on your own? Here is your problem. Looks a little different. I moved the constants over, but it doesn't matter. So why don't you see if you can decide what you would multiply by to eliminate. You might have to multiply both equations. For y, walking around, most of you canceled your x. If you want to get rid of these, what would you have to turn them both into? 15. So you'll have to take this one times 5 and this one times -3, or you could do the top one times -5 and the bottom one times +3. A couple of you eliminated y. You can turn 6 and 4 into 12. So take the top one times 2 and the bottom one times 3. So either way. So you have to take everything times your 5. Add and those cancel, so we get -42y minus 7 equals 0. Divide by -42 and you get a -1/6. I do want fraction over decimal. I don't want you to round a decimal, so just keep it exact. Once I have my y, I can plug that into one of the equations to solve for my x. So if I just put it into the first one, -6 times -1/6, that's a +1. So I get 3x minus 1 equals 0. Add your 1, divide by 3, and it's 1/3. So our answer is 1/3 -1/6. So far, so good? I just have a couple more that I would like to look at. So all of the ones we've solved so far gave us just a single answer. But that is not always the case. We talked about with inconsistent, you might have two parallel lines that never meet. Or I could give you two equations for the same line. So I want to solve a couple that look like that don't just come out to one nice solution. So substitution and elimination is still our strategy. If you wanted to eliminate on this one, what would you have to do? Take the top times -2. We get -4x minus 2y equals -10. And 4x plus 2y equals 8. When I add these together, my x's cancel and my y's cancel. So we just get a 0 equals -2. That's a false statement. 0 does not equal -2. So what does that tell us? No solution. I do also want, and the directions will say that, you have to identify any inconsistent system. So anytime you get no solution, it is inconsistent. You need to write both. So you need to say no solution, inconsistent. These lines are parallel. They would never meet. So again, you'll know that anytime you solve and your variables cancel and you're left with a false statement. 0 equals 5, 0 equals -2, those kinds of things. Let's look at this one. If I wanted to eliminate my x, what would you have to multiply by? Let's think about it in terms, if you wanted to get rid of the 1/3, what would you have to multiply by? A 3. And we want to turn it into a 6, So then you'd have to multiply by 3 into 6, which is 18. So you could do it in 2 steps if you needed to, or we can just say, okay, let's take the top one times 18. So 1/3 times 18 is like 18 divided by 3, so that's 6. 1/6 times 18, so 18 divided by 6 is 3y. 2/3 times 18 would be like 36 divided by 3, so that's 12. When I add these together, on the left, both things cancel, so we have 0. On the right, 12 plus -12 is 0. So everything canceled, but unlike the last one, 0 equals 0 is a true statement. So this one has a solution. What it means is these are two equations for the same line. So every point on that line is a solution. This is probably the one new piece. In Algebra 2, you would just write infinite solutions and stop there. We're going to be a little more specific this year. So our directions say write the solution set with y arbitrary when we have infinite solutions. In other words, if I say keep y arbitrary, I want to write an ordered pair with y as the variable. So I have to come up with something for my x. So what you're going to do is take one of these equations and solve for x. Okay, let's do the second one. We'll avoid the fractions. So if I wanted to get the x by itself, I would add over my 3y. And then I would have to take everything and divide by -6. So x is 2, 3 over -6 is -1/2 y. So if I say y arbitrary, you have to replace your x with an expression involving y. So we just take one of them, solve for x, and that's how I describe my ordered pair. If I had said x arbitrary, I would have kept this as an x, and then I would have solved for my y. So that is the only twist, the only new thing. It's just how we write those solutions. Do we need another example like that?
Yeah.
Okay, thank you. Let's look at this one. So if I am doing elimination, you would take the top one times -2. So when I add those together, my x's cancel, my y's cancel, I get 0 equals 0. So is this a no solution or an infinite solutions problem? Infinite. So I said write it with y arbitrary. So in your ordered pair, the y stays. You have to replace the x with something. So take one of your equations and solve for x. So that's probably easiest with the first one. If I want the x by itself, I just subtract my y. So the x is 4 minus 2y. So that's just a way of describing all the points on that line. We have about 15 minutes left of class. There is a math Excel assignment, so I want to give you guys time to work on that and ask questions.